The Matrix and Corolla both utilize an improved version of the 1zz-fe 1.8-liter 16-valve dual overhead cam engine found in last year's Corolla. But the Matrix goes one step further with the available 2zz-ge 1.8-liter engine. This aggressive power plant was introduced on the Celica GTS. Let's take a look at both of them, starting with the 1zz-fe. While the 1zz-fe is basically the same as last year's, its improvements have resulted in better horsepower and torque and an ultra-low emission vehicle rating in the Corolla and the two-wheel drive Matrix. For 2003, the 1zz-fe produces 130 horsepower at 6,000 RPM and 125 foot-pounds of torque at 4,200 RPM in the Corolla and the two-wheel drive Matrix. When coupled with the Matrix four-wheel drive transaxle, the 1zz-fe produces 123 horsepower at 6,000 RPM and 118 foot-pounds of torque at 4,200 RPM. Changes for 2003 began with a different intake camshaft profile for more power in the low to medium speed range. The variable valve timing range has also changed for improved performance. The intake manifold has been changed to resin for lighter weight and less heat transfer from the cylinder head. This reduces intake air temperature for improved intake volumetric efficiency. A resonator has also been added to optimize intake pulsation for improved engine performance in the mid-speed range. The diameter of the throttle body has also been increased for increased output. The exhaust system has also been changed. On the Corolla and the two-wheel drive Matrix, the stainless steel exhaust manifold uses shorter branches and a dual pipe convergence area for faster warm-up of the number 1 three-way catalytic converter. On the four-wheel drive Matrix, a smaller number 1 converter is integrated directly into the manifold. Both the upper and lower heat insulators now have cooling holes to help ensure exhaust manifold cooling performance. 2 three-way catalytic converters have been adopted for 2003. Because of the larger capacity of the number 1 converter on the two-wheel drive Matrix and Corolla, the number 2 oxygen sensor is located between the 2 converters. On the four-wheel drive Matrix, the number 2 oxygen sensor is placed after the second converter. The number 1 oxygen sensor on both configurations is a new planar type that was developed to meet more stringent emission regulations. This new oxygen sensor functions like a conventional sensor but with some improvements. It heats up faster, allowing the ECM to go into closed-loop fuel control faster when the engine is cold, thereby reducing cold start emissions. The heater is embedded in aluminum oxide. When the heater is on, the aluminum oxide conducts heat directly to the zirconium dioxide layer, bringing the O2 sensor to operating temperature quickly. The planar oxygen sensor has the same detecting range and signal characteristics as the previous cup element oxygen sensor. In closed-loop mode, the cycling between rich and lean is the same as the cup element oxygen sensor. The major differences are that it goes into closed-loop fuel control faster and the heater element has a different resistance value. There's also an O2 sensor socket SST for use on the four-wheel drive Matrix. See the 2003 Corolla Matrix repair manual for complete details. A single cooling fan is used for both the cooling and air conditioning system. The ECM determines low or high-speed fan operation based on engine coolant temperature and the AC pressure switch signal. This year's 1zz-fe also uses the new planetary segment, or PS starter motor, highlighted on the 2002 Camry. Smaller and lighter than the previous starter motor, the PS starter uses square-shaped wires in the armature coil to increase output torque. It also uses permanent magnets rather than field coils to maximize magnetic flux and increase torque output. The solenoid is replaceable on this new starter motor as a service kit. Iridium spark plugs are also used in place of platinum on the 1zz-fe for increased durability. The engine control system on the Matrix and Corolla now uses a reprogrammable 32-bit CPU in the ECM and a built-in AC amplifier. One change unique to the automatic-equipped Corolla is the use of two different ECMs, a Denso unit and a Delphi unit, depending on the plant it was manufactured in. Their functionality is identical, but their size is different, so they are not interchangeable. Because of the new ECM, the length of time to clear DTCs from the ECM memory using the battery terminal has been lengthened from 10 seconds to a full minute. A new type of flat knock sensor is used for 2003 that is more sensitive over a wider range than a conventional sensor. A conventional sensor uses a vibration plate which has the same resonance point as the knock frequency. However, the knock frequency can change depending on engine speed and load, which limits a conventional knock sensor's ability to detect it. The flat-type sensor can detect the vibration even when the frequency changes. This means increased sensitivity and more precise ignition timing control. The sensor is bolted to the cylinder block and consists of a steel weight located in the upper portion and a piezoelectric element located under the weight through an insulator. When knocking vibration is transmitted to the steel weight, its inertia causes it to contact the piezoelectric element, which generates a signal to the ECM. This signal, along with other sensor signals and the ECM's programming, will determine ignition timing. An open circuit detection resistor has also been integrated into the sensor for easier diagnosis. This resistor is connected in series to a fixed resistor in the ECM. If an open circuit occurs between the knock sensor and the ECM senses the voltage change and stores the diagnostic trouble code P0325 in memory. The Matrix is also available with the 2zz-ge 1.8-liter engine with VVTL-I that you're familiar with from the Celica GTS. It produces 180 horsepower at 7,600 RPM and 130 foot-pounds of torque at 6,800 RPM. The intake manifold shape has been changed to accommodate the Matrix engine compartment. The PS starter motor is also used. Like the 1zz-fe, a single cooling fan is used for the cooling and AC system, and the same flat-type knock sensor we looked at on the 1zz-fe. But the highlight of this engine is its VVTL-I technology. Let's review it. To accomplish variable valve lift, the intake and exhaust camshafts have two sets of cam lobes, a low to medium speed lobe and a high speed lobe. A rocker arm mechanism is used to control which set of cam lobes operate the valves. The rocker arm mechanism consists of the rocker arm pad, rocker arm pin, and rocker arm shaft. A needle roller is integrated into the rocker arm. Valve adjusting shims are fitted to the end of the valve stems. An additional oil control valve has been added to the rear of the cylinder head to control the changeover mechanism. When engine speed is below 6,000 RPM, the low to medium speed lobe pushes the needle roller of the rocker arm down to operate both valves. Although the high-speed lobe is also pushing down the rocker arm pad, the pad moves freely or gives, so this movement does not affect valve lift. When coolant temperature rises above 140 degrees Fahrenheit and engine speed is higher than 6,000 RPM, oil pressure extends the rocker arm pin, which locks the rocker pad in position. Because the high-speed cam has greater lift and duration than the low to medium-speed cam, it now controls the movement of the rocker arm to operate the valves and increase valve lift. VVTL-I activation can be checked using Active Test in the diagnostic tester. When activated at idle, the engine will run rough or stall when it switches to the high-speed cam. This test verifies operation of the valve lift mechanism. You can find complete details in the 2003 Corolla Matrix Repair Manual. Another change on the 2003 2zz-ge is the use of a short-body O2 sensor. This was previously used as a sub-O2 sensor on other 2002 Toyota models. This sensor uses the conventional cup-type element in a shorter body. Signal operation and diagnosis are identical to a conventional oxygen sensor.